Yo, 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 it's Miss A, and we are talking about 5 steps to drawing the Lewis structures. Yay! All right, so let's go over. It is really, really simple. You just have to follow the steps. Once you practice enough, you'll get right into it. Okay, so step number 1 is find the total number of valence electrons. This is pretty easy. And how do we do it? We just use the periodic table. So let's go with an example. Let's say we have H2O. All right, so I look on the periodic table. Remember how to find the valence electrons? Remember valence electrons are your outer shell electrons? Remember how you find it on the periodic table? You just, count across. So this row has 1, 2, we go here, 3, 4, 5, 6, 7, 8 valence electrons, right? So how many does hydrogen have over here? It has 1 valence electron. So hydrogen has 1 valence electrons, but there are 2 of them. So I have to multiply by 2, 2 here. All right, so we have 2 electrons for hydrogen. Now let's look at oxygen. Oxygen has how many? Well, I count, it has, it's in group 6, it has 6 valence electrons. So 1 times 6 is 6. We add them together. We have, water has 8 total valence electrons. All right, let's try a different one. Let's try cyanide, Cn minus. Well, let's find carbon on the periodic table. So carbon is right here, group 14 or 4. So 4 valence electrons here. Nitrogen is right next to it. It has 5 valence electrons. 4 plus 5. But wait, what is this little negative? We know what that negative means. It means that there's an extra electron. So plus 1. So it equals 10 valence electrons. Cyanide has 10 valence electrons. Now, I just want to remember that the valence electrons are really super important. Not only are they the outer shell, they're the ones that interact with the world. They're the ones that have our bondings. They're the ones that start our chemical reactions. Okay? Super important, guys, these valence electrons. All right, on to step number 2. Step number 2 is put the least electronegative atom in the center. So the least electronegative atom goes in the center. All right, so what am I talking about now? Hopefully you guys can read my handwriting. Okay, so let's look at this. Now remember from the last unit, fluorine was the most electronegative. And then everything going this way got smaller, and everything going down this way got smaller as well. So when we're looking for the least electronegative, we are looking for the atom that's furthest away from fluorine. So I'm just going to write that here. So furthest from fluorine. Okay, so let's look at some examples here. Let's look at NO2. NO2. So when I'm drawing my Lewis structure, what goes in the middle? Well, I look over here. Let me change the color for us. Let's go this purple. So I have nitrogen, which is here, which I just wrote all over, and oxygen, which is here. Which is furthest from fluorine? Well, obviously nitrogen. So I would put nitrogen in the middle, and my oxygens go on each side. All right, let's try another one. Let's try PCl3. Okay, on my periodic table. Here's my phosphorus, and where's my chlorine? My chlorine is here. Which one is closest to fluorine? Well, chlorine is closest, so it is higher electronegativity. So the least electronegative atom in this case is phosphorus. So phosphorus would go in the middle, and you'd have the Cl's surrounding it. All right, what about if we have something like HCl? Well, HCl, there's only 2, so we don't have a middle one, so it will just be next to each other, as it is there. Super. All right, step number 3 is you put electrons between all of the atoms. Put electrons between all atoms. Now this signifies your bonds. That's it. It just signifies your bonds. So let's go with this HCl example. Let's see, I'll go blue again. So we have HCl. All I do is I put electrons, and I put 2 electrons because 2 electrons are a bond, right? 2 electrons are a bond. That's it. That's all I do. Put them on there, right? Okay. Let's move to step number 4. Hope I have enough room. Step number 4 is complete the octet on the outside atoms. So complete octet on outside atoms. All right. I know you're saying, Miss A, what in the world are you talking about? What is the octet? Remember the octet rule that all atoms, if we're making them like a person, personifying them, they want 8 electrons around them. They want to be perfect like these noble gases with 8 electrons around. Most stable, full outer shell. All right, so what do I do? Well, let's go back to this hydrogen chloride, and I'm going to put 8. I'm going to fill it around. So now chlorine has 2, 4, 6, 8 electrons. Woohoo! Yay! I completed the octet rule. It has 8 electrons around. Remember, you must have 8 electrons around atom. Except there is a exception, right? The major exception is hydrogen. Hydrogen only wants 2. Exception, exception, exception here. Exception. Hydrogen only gets 2 electrons. Always, 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 always. Okay? Another rule about hydrogen, which I didn't say before, was that hydrogen is always on the outside. So another rule, we never put hydrogen in the center. So hydrogen is always on outside. Never a central atom. Never, 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 never. Okay. All right. That seems easy enough. Okay. Now, let's go to the 5th step. All right. What happens if you run out of electrons? You just don't have enough electrons to fulfill the octet rule. So, when you run out of electrons, move electrons from outer to inner. And I know you're like, Miss A, I have no idea what you're talking about. Let me just do a quick example right here. I'm going to do it in red so that you can see it. Sorry, my paper's moving all over off the video screen. Okay, let's take an example like O2. All right, so let's start with all the steps and go through O2. So how many valence electrons do I have? Well, I look at oxygen. I count 1, 2, 3, 4, 5, 6 valence electrons, but I have 2 of them, so I have a total of 12 valence electrons right there. Let's use this little space, okay? Number 2 is least electronegative. Well, there's only 2 of them, right? So I just have to go oxygen and oxygen. All right, put electrons between all atoms. Perfect. 1 here and 1 here. Easy enough, okay? That was step number 3. Now it says step number 4, complete the octet on all of them. All right, so I have 2, 4, 6, 8, 10, 12. Well, uh-oh, something's going on here. I have 12, but, well, this is the octet rule, 2, 4, 6, 8, perfect. But here, I only have 2, 4, 6. Not good. Not good. So what do I do? Well, I'm going to move one of these here. So I'm going to take these electrons and I'm going to move them here. Right? Can you see that? I'm going to take these electrons and move them here. So you're going to get something that looks like here. Here's my 2 oxygens. I got so 2, 4, 6, 8, 10. Whoop, I made a mistake here. So get rid of these. So 2, 4, 6, 8, 10, 12. Now I have 12. Does it fit the octet rule? Well, let's see. If I count these, 2, 4, 6, 8. Yes, this oxygen has 8 electrons. Now let's check this one. 2, 4, 6, 8. Yes, this has 8 electrons. This fulfills the octet rule. That's it. As easy as that. That's how we do it. That's how we draw the Lewis structures. All right. So, how do we learn this? Well, the best thing that we do is practice. Practice. You learn the 5 steps and you practice, practice, practice. And we will practice. So that's it. Miss A is out of here.